Assalamualaikum warahmatullahi wabarakatuh and a very good day to all. We are from Group 4 and we'll be presenting about sustainability. Our team members consist of Muhammad Iskandar, NUSRAH, Sarah, Muhammad Muaz, Muhammad IRFAN and HAIKAL SAFIY. The main contents of this presentation are about spatio-social innovation level, socio-technical system innovation level, and lastly is about discussion and conclusion of TFS evolutionary framework.
So, the first point of our presentation is design for social innovation. It was a combination of the technological and social innovation to achieve sustainability. Then, the second point is technological innovation is mainly focused on tackle radical changes on environmental issues and it mainly put by the government itself. For example, in Malaysia, there is an initiative by the government that is being called as Green Technology Master Plan. It is to reduce environmental impact and enhance sustainability. While social innovation is more on to tackle social problem and social changes for the better. These two fields of sustainability design used to be separated and it is just recently being emerged. Social innovation also could be described as the creative recombination of existing resources while not totally rely on technological approach. It emphasizes more on the role of people and community itself in driving changes. In this design, it usually had a collaboration between local institutions like NGO and the experts to tackle the problem. The function of this design is to make social innovation more likely, effective, long-lasting and widespread. This could be driven by both local community itself and the experts, but designer play more important role as they are the one responsible to make the design more attractive and visible. Currently, according to the research by the article, the focus are now shifted on exploring the role of designer and the development of tools to support the designer. And then, of course, there is a challenge and criticism on doing this design. So the first challenge and criticism received during this design are the solution given by the experts might be superficial. It is mean that the same problem could occur again in the future as it is not settle the root problem. And the second problem is the cost of this design and service could be really high because it is to pay the designer itself and the service might be really pricey. So that's all from me. Let us move to the example of this sustainability design. Now, let us move to an example of design for social innovation. So, imagine there are one village that had a problem on accessing the safe and clean drinking water. So, the first step is they need to identify the problem and after that, go and consult with the experts to come up with a possible solution. Then, they need to move to ask for local institution for the involvement in this matter, in which it is to provide supports and funds. After that, in the implementation of ID process, both experts and local institution should be working together on designing and building this waterproofing system, in which it is the solution for the problem. And while on doing that, they could encourage the community engagement by including them on building this project. Then, after the project was settled, the experts and the local institution should provide them with education and training for the local communities so that they could use the waterproofing system properly. And then they should teach them on doing the maintenance so it could cut the cost. Then, lastly, of course, the main point for this example is it is to achieve the sustainability. So, by teaching them how to use it properly and doing the regular maintenance, it could achieve our goals to achieve sustainability in this problem. So, that's all from me. Thank you.
Moving on, we'll be discussing about systematic design. Firstly, what is systematic design? It is a nature-inspired approach by mimicking our natural ecosystems. where it seeks to not just create industrial products but a complex industrial system. This approach is to implement a sustainable productive system into our economy, in which materials and energy flows are designed so that waste from one productive process can become input to other processes, preventing waste from being simply released into our environment. By taking this step, it can potentially resulting in new locally based value chains. For your information, this system has been applied in several projects globally, focusing on a variety of areas, for example like agricultural and food networks, industrial processes, water treatments, and more. This is an example of systematic design, which is coffee product. We can understand that from coffee product, we will have coffee waste. But instead of we just throw out the waste, this coffee waste can actually be an input to other processes. For example, like as a source of lipids and waxes for pharmaceutical productions. It can also be a help in substrate for farming mushrooms, and it can be the medium to grow worms in vermicompost. But we are concerned on the main problems that might arise from this approach, because this approach only focused on production aspects without addressing the real issue of reducing individual consumption. And this approach does not affect consumer demand for products and services. Therefore, systematic design should be combined with other design approaches like product service system design or design for social innovation. Design for social innovation will be presented by my friend Irfan.
So let's we proceed to the next point, which is about the socio-technical system innovation level. In the 1990s, the design profession began to address environmental and social issues through frameworks like green design and eco-design. Notable projects from that era include the Dutch National Interministerial Programme for Sustainable Technology Development, STD, and the European Union funded strategies toward the Sustainable Household (SUHAMI) project. So in the first one, Dutch National Interministerial Programme for Sustainable Technology Development (STD) aimed to influence sustainable innovation through policy development. It also employed a backcasting approach, which involved envisioning a desirable future state. Second, European Union funded strategies toward the Sustainable Household (SUHAMI), which aim to influence innovation that contribute to sustainable living. It also focused on developing design-orienting scenarios. Development of the multi-level perspective of system innovation (MLP). Based on evolutionary innovation theory, MLP is a theoretical framework that first appeared in the 1990s. The article also mentioned the development of managerial theories and approach aimed at influencing and steering transition, including strategic niche management and transition management. Design scholars have started to integrate MLP and related theories into their work. Examples of this integration include exploring connection between product service system, PSS design, and system innovation and transition, as well as developing a theory of design for system innovation and transition. Additionally, the article highlights the use of living labs and other experimental approach in design for social innovation and emphasizes the importance of designing a variety of interconnected experiments. Overall, the article underscored the effort to create more sustainable and culturally transformative solutions in complex socio-technical systems. The next point, the article discusses the concept of design for system innovation and transition, which is a multidisciplinary approach aimed at transforming socio-technical systems through various forms of innovation, including technological, social, and organizational and institutional changes. This approach encompasses two main aspects, which is the first one is product service system, aims to transform production consumption system through innovation in business model. Second, social innovation. This approach emphasizes social change without being dependent on technological change. More recently, there has been a shift toward focusing on cities as system of socio-technical system. This perspective on urban design and planning differs from traditional approach in several ways, which is the first one is complex adaptive system, acknowledging the intricate interplay between technologies, ecosystem, social and cultural practice. Second, integrated approach, which is a design for system innovation and transition integrate various theoretical domains. And the last one is multidisciplinary design approach, in which is achieving sustainable urban transformation requires using a variety of supportive design approach. As an example, the Veteran Eco Innovation Lab in Australia Vision and Pathway 2040 project serves as an example of design for system innovation and transition. This project used design-led visioning to produce enticing ideas for resilient and low-carbon Australian urban futures. Creating glimpse of the future or picture of desirable, resilient and low-carbon urban situation is the project's main accomplishment. Created through multi-stakeholder participatory process, this view comprises many layers of city system such as entire cities, precincts and neighborhood. The Vision and Pathway 2040 project is a prime example of how design-led method may be used to plan strategically and collaboratively with important stakeholders to imagine and create more resilient and sustainable urban future.
Next, we move to the table of main characteristic design for the sustainability approach. There are three levels of main characteristic of DFS approach. First is product innovation level. First approach is green design, which is focused on reduce the negative environment impact on products and system by minimizing the energy consumption, resource use and gas emissions. There are some limitations, which is green design can be more expensive due to use of eco-friendly materials and technologies, which can limit its adoption, particularly in cost-insensitive industries. Also, there are potential future research direction, which is exploring potential synergies with other approaches. Next is second is eco design. The focus is lowering environmental impact, focusing on the whole life cycle of products from extraction of raw materials to disposal. They also have some limitation, which is focused on only on environmental problems and disregards problems, which cannot be accounted for in life cycle assessments. Then they also limit consumer awareness and willingness to pay a premium for eco-friendly products that can influence the adoption of eco-designs. They also have potential research direction, which is developing tools to support decision making at managerial and strategic level. Next, we move to the second level, which is spatial social innovation level. First approach is design for social innovation. The goal is generate positive social impact by addressing and solving social issues such as poverty, healthcare access, education and community development. Their main limitation is involves changing people's behavior or attitudes, which can be challenging and require careful consideration. For potential future research direction is further explore the role of design in social innovation processes, particularly in replication and scaling up. Also develop social innovation toolkits. Second is systemic design. The main goal is designing locally based productive system in which waste from one productive process become input to other process or output. Their main limitation is the approach is mainly focused on the production aspects without addressing the issue of reducing individual consumptions. There also future research direction, which is exploring synergies with other approaches. Last is socio-technical system innovation level. There are one only approach, which is design for system innovations and transitions. The main goal is transformation of socio-technical system through strategic design. Their limitation is not always provide straightforward solution and need to be supported by approaches that focus on development of products and services that can be part of new socio-technical systems. Their potential future research direction is developing theoretical insights and practical tools to linking micro innovation with macro innovations. That's all from me. Thank you.
And then I will be explaining about the discussion and the conclusions of this presentation, which is the DFS evolutionary framework has the sustainability oriented innovation, which is the innovation for environmental and social benefits have evolved from a narrow technical, product and process-centric focus towards a more large-scale system-level change, which led to a broader perspective. There are two main point of this sustainability-oriented innovation, which is the technology people and insular and systemic, which is the technology and people is a shift from only a technical and incremental view of innovations and towards one that recognizes sustainability as a socio-technical challenge. The second is the insular and systemic. It is the shift from innovation that solve the firm's internal challenge to a focus on changing a larger socio-economic systems, which you can see here from this slide. The figure 1 shows that it is before the sustainability oriented innovation. We have the socio-technical system level, spatio-social level, product service system level, and product level. But after the sustainability oriented innovations, it has more broader design, which is the design for system innovation and transitions, design for sustainable social innovations, product service system design for the base of the pyramid, sustainable product service system design, eco-efficient product service system design, the product design for the base of the pyramid, the design for the sustainable behavior, the emotionally durable design, the eco design, green design, biomimicry, cradle-to-cradle design, and lastly the systemic design. Well then, I will be explaining about the reflections and observations emerging from the DFS evolutionary framework, which is at the first half of the year of the 1990. The DFS focused more on the product level, which is the green design and the eco design were two important approaches during the periods. At the late 1919, the additional approach related to product level sustainable emerged, that is biomimicry, which is the innovative approach to design and problem solving that draw inspiration from the nature time tested solutions. At the early 2000s, the introductions and the developments of several more approaches at the product level, such as cradle-to-cradle design, emotionally durable design, design for the base of the pyramid, which is the BOP, and design for the sustainable behavior, which still used in the academic research, was introduced. And in the year 2000 also, there are product service system design, which started to gain a significant momentum and contribute to the development of the PSS design approach. And there is also the spatial-social level was introduced, which focused on applying design principles to confront and solve social challenge, while also encouraging good societal change. This area is increasingly gaining research attentions in the design school. Well then, the GFS have focused on evolving from a single product to a complex system. It is because many had realized the significant aspect of the sustainability. The focus is the primer focus of this is a technical aspect of sustainability. Then the one that follow recognize the importance of the role of the users, the community resilience, and the various actors, and also the dynamic in socio-technical systems. It is also concentrated on the environmental, which is initially the DFS approach primarily concentrated on environmental sustainability aspect. This means that the primary concern was making product and processes more environmental friendly with a focus on reducing resource consumption, pollutions and waste. And lastly, the comprehensive view. As the DFS had progressed, newer approach had adopted a more comprehensive view of sustainability. This expansion involved considering a broader set of concerns that go beyond environmental issue. These additional concerns include the labor conditions, poverty alleviations, inclusion of marginalized individuals, social cohesion, democratic empowerment, and lastly, the overall quality of life. To add on, some of the DFS approach are not mutually exclusive and often overlap and complement each other. Only a few of them with a such clear distinction can be observed, like the emotional durable design and the systemic design, which have a completely different focus and no point of contact at all. But the design for the social innovations and sustainable product service system, which is the PSS design, share elements and can be combined. Second point, some DFS approach also complement each other, providing strategies for improving environmental performance, like the eco-design, emotionally durable design, and design for sustainable behavior, which offer a complementary strategies at the product innovations level. The frameworks shows how certain the DFS approach have evolved into others, such as the connection between the green design and the eco design. And it must be highlighted that some approaches are not limited to the single innovation levels, and they can cross over various innovations level. The connections between the DFS approach and the concept of circular economy, which is also known as CE, which is seen as a potential option to promote environmental conservation without slowing down the economic growth. It aims to create a restorative and regenerative industrial economy. Within CE, which is the circular economy, it emphasizes the importance of the 3R principle, which is the reductions, reuse, and recycling. Therefore, several DFS techniques are essential in the process of using the circular economic solutions, which is the cradle-to-cradle design. The biomimicry design can help select the materials and design product for a closed-loop materials flow. The eco-design is capable of managing the complete product life cycle by incorporating the 3R principle. The systemic design can be used to design a product and industrial system based on industrial ecology principle. And lastly, the product service system design is essential for designing business model that support CE. The design for the system innovations and transition can suggest different forms of circular economy for a new socio-technical system scenarios based on a variety of political economic assumptions as a result. Regardless of the fact that all DFS approach can contribute to the circular economy in different ways, the concept of CE has primarily focused on technical focused DFS approach.
Now let's move on to the reflections and observations on the importance of each DFS approach. Firstly, sustainability is a complicated socio-technical issue. Lower-level strategies that concentrate only on product innovations are important, even though they might not be enough to achieve this sustainability. Why is it complicated? It is because sustainability requires a lot of combinations of DFS approach that have different level of innovations. For example, the achievement of community based on product services system, that innovations depends on well-designed materials of artwork. DFS also require a systematic analysis and way of thinking in the method of analysis. The goal of design for system innovations and transitions is to transform system through combining the actions and strategic choices. This is made by the designs and innovation teams with long-term visions of a completely new system. Now, let's look into the reflections and observations on the knowledge and know-how related to each DFS approach. Firstly, the passage discussed the evolutions of DFS and the changing skill set that required by practitioners to implement these approaches effectively. DFS is now more focused on the complex system than on individual products, and there is an increasing demand for expertise in human-centered design. So what is human-centered design? It is a problem-solving technique that puts real people at the center of the development process. Next, it also focuses on the product innovations like eco-designs and also green design. This design is heavily dependent on the technical know-how in the production processes and materials, and also instruments like life cycle assessment. This technical know-how refers to on the practical knowledge to solve the practical problem. For example, project management required using a complex program and system. For example, in the designs of product service system, it is meeting new customers that need to create a new business models that understand truly of the users. In conclusions, the way that DFS technique have developed to tackle large product, more systematic problems is highlighted on the importance of human-centered design in expertising. In conclusion, the framework illustrates the ways in which the difference of DFS approaches in contributing to specific sustainability aspect, and also visually represent the connect and also cooperations among this method. In education's point of view, the framework might be useful in designing the courses to communicate with the students the richness and complexity of the DFS fields. Next, in design practice point of view, DFS also be used as a tool to support organizational change in the organizations. Lastly, from an academic point of view, the frameworks also provide the discussions around DFS and seek the encourage of the scholars to involve in the research of studying this design.